All right, number 3 is kind of playing off number 2, just a little different scenario. Put another twist on it. It says if the aquarium above, in the aquarium above, suppose the glass for the sides is $4 per square foot, and the glass for the bottom is $10 per square foot. So that's going to change things a little bit. Provided the volume is 36 cubic feet, so that's still the same. Length is still twice the width. What dimensions would minimize the cost? So we're trying to minimize something else here, the cost. Now, if everything costs the same, it would be kind of the same as last problem, right? That minimum surface area would give us a minimum cost. But since the bottom costs more than the top or the sides, then it's going to change things a little bit. But a lot of the stuff we start off with is the same. For example, our picture and dimensions are all still the same. All right, so we're starting off the same there. We're just trying to minimize cost now. So our total cost is going to be the cost of the sides plus the cost of the bottom. So the cost of the sides, we know it's $4 per square foot. Well, that's going to be $4 times the area of all the sides. So we kind of figured that out in the last problem. Right, the front, the back, the left, the right, all of that, those are the area of the sides. All of that ended up giving us 108 times w to the negative first. And when we figured that out, those area of the sides came out to that. So we have 108 times w to the negative first. Plus, the cost of the bottom is going to be $10 times the area of the bottom. And the area of the bottom was just 2w squared. Now, if we were doing this problem from the very beginning, we'd have to kind of go through that whole process. But we've already done a lot of that work, so we can just kind of reuse that here. So our cost is going to be $432 times w to the negative first plus 20 times w squared. So we want to figure out the derivative to find the critical value. So we get negative 432 times w to the negative second plus 40w. And we want to know when that's 0. So we can factor out an 8w to the negative second here. And if we take an 8 out of here, we get negative 54 plus 5w cubed. So again, this is just going to give us a w equals 0. That makes the derivative undefined, but we can't have a width that's 0. So we're going to figure out what makes this 0. So w cubed equals 54 over 5. So we can take the cube root of that to get w. So 54 divided by 5 to the 1/3 power. We get 2.210. That's about 2.21 for our width. And again, we can check to make sure that's a minimum. 2.21, derivative is 0. If we try like 1 into our derivative here, if we put 1 in here, it's going to be positive. 1 in here, it's going to be negative. So that's a negative. If we put 3 in, this is still positive. This one becomes positive, so this is positive. So we do have a minimum at 2.21. And again, it's asking for the dimensions. So our width is 2.21 feet. Length is going to be twice that, so 4.42 feet. And then our height we're taking 18 divided by 2.21 squared. So we get 3.685.